I'm Joan.
Uh-huh.
Very
I'm
good, thank you.
impressed.
I am
That's a great
impressed.
program.
No, you have to help us.
Jackie.
Kathy,
Uh-huh.
Okay.
well, you're a,
Jackie.
Oh,
this is the Jackie.
Oh, yeah.
Well, everybody's in their assigned seats, I see.
Yeah. See, see.
you got so quiet.
Watching the clouds roll up.
Jerry, was there exercise this morning?
Yes, there was.
Yeah.
And they'll be there tomorrow morning also.
In the heart. Yes.
Yes.
Here, don't spend too much. I can.
What?
Yeah.
Well, I'm not
Oh,
sure.
and then the
The chapel, I think, I'm not sure.
That's why I get
We'll have to find out.
Yeah.
I came one note from the sun.
Right at the beginning. Well, the getting's good. Get while the getting's good.
Yeah.
Yeah. I don't know if I've done that once, you know, before, so it's a little bit weird.
I remember you from Channel 6.
Oh, that was a long time ago.
Oh, no.
But thanks for remembering. It's so funny, I still ran it for about the first five,
Just like
even almost 10 years old. I would
I didn't
look
realize
up and say sometimes,
Wow. Yeah.
oh, I watch you all the time, and I'm like, that's pretty interesting. They must have somebody who looks like me. It's been a long time since I've been in front of a camera.
I didn't realize I did so much.
Oh, I know. Well, I left the office stuff in the house. So, the house has theirs, you know. I left stuff.
Yeah, there's still choices out there, and the
Oh, yeah.
cadre of TV meteorologists in town are still, okay, so to show you how old I am, Tom Watts was, for many of the years that I was at Channel 6, he was our Grafton weather watcher, or Mequon weather watcher. And I still remember he came to the station once, he was a young boy, his mom brought him for a tour of the weather office on a Saturday evening. Hung around with me, that was pretty funny. Now, here he is, does a great job.
From Wisconsin to Florida.
Heart of the nation, Mass. Yes. Yes. That's where we record that over at the
Hi, Sister
at the
Rita.
Sacred Heart Church.
You're not in the
49th
proper
and
place.
Lee.
I gotta keep you
I
guessing.
believe that
I've
that's
been
a,
look around and see that everybody's sitting where they were yesterday.
I believe that's a Croatian
I
Eastern Rite church. Yeah.
Well, that's a good way to put it.
5 minutes, 5. Countdown. The countdown. Thank you, thanks. Oh, that's very nice of you.
The program yesterday was excellent.
Yeah. Yeah, you're welcome, thanks for coming.
Hi there, how are you?
Okay, when you go in the middle of doing
Oh, here we go.
Just hold it.
I get opportunity.
Yeah.
the rest of it.
Nobody give them a rock band, so you don't want to go halfway.
You could sit out for a
I really like it.
You left it behind.
No,
And
I
you're
said.
Oh, I can imagine.
Yes. They would tell you.
Hello.
Yes.
Yes.
I'm you, Sharon.
Can't have my pictures there. To marry out.
Geometry. I'm on the first floor. It's
Oh, that's right, and your number?
107, right
okay.
And where are you? Because otherwise they'll start. Oh, okay.
Yeah, we're the same. The lady said,
I didn't want to say raffles.
this should be very interesting. I really like to watch the weather.
Yes.
I
How
found
they
it,
predict things and
Catch.
and I've noticed that since I've moved here, I've adopted
I know.
I don't know, I mean,
It's really
and I don't know how detailed I am to equipped to understand. Yes. And they look
it's like if you're all walking.
right. Especially if you don't have an umbrella.
I've been caught about 3 times on that, walking around and I didn't find. It's funny, I looked on the computer, and it's by medicine, I have enough time. That number was quite interesting. It didn't quite work that way. One time I was on the walking track, and I was all the way down to and then I just came in a different door. I came in a different door.
And fortunately, we're kind of washed away. Right.
This is all washed away.
All right, 1 minute.
Oh, hello there.
33 seconds.
Time's up.
I told you, when I meet my friends out, or we go out or something, when we say we're meeting at 5, if we're not there at 4:45, we're late. Like, we're always early, so we're late. But when you said 5, well, it's 4:45, 4:47, yeah. I'm always, I want to be on time.
Oh, yeah.
All right, okay, let's get started. So, this is Mr. Bart Adrian. Let's give him a nice thank you word of welcome. And I'm gonna let him take it over and introduce yourself and everything, so thank you.
Very
Go ahead and use the microphone, because they'll want you to.
Thank you, Shelley.
Yes, you're welcome.
Well, it's really my pleasure to be here today, and of course, being in this kind of a setting, I take and exercise full latitude to share some words that are dear to my heart to start things off. So this is from the book of Job, chapter 37. Of course, you're all familiar with the story of Job, who was having a very hard time with all of the difficulties that befell him, and one of his friends was trying to counsel him that, you know, there's a way of looking at it. And here's what he said. I love this passage. God thunders wondrously with his voice. He does great things which we cannot comprehend. For to the snow, he says, fall on the earth, and to the shower and the rain, be strong. He steals up the hand of everyone, that everyone may know his work. From its chamber comes the whirlwind, and cold from the scattering winds. By the breath of God, ice is given, and the broad waters are frozen fast. He loads the thick cloud with his moisture. The clouds scatter his lightning. They turn round and round by his guidance to accomplish all that he commands on the face of the world, whether for correction or for his land or for his love. He, the Lord God, causes it to happen. Amen. Amen. I love that passage. In fact, I love it so much, I actually inserted it in the just before the preface page in my master's thesis, and I was a little nervous that my major professor might question what's that doing in there, but being a good Christian man, he was more than supportive of my leaving it in there, so that's where it sits to this day. Okay, well, let's start off, a picture is worth 1,000 words, so let's start off with a picture here. Anybody have any idea who this is? Yeah, that was me a little while before I grew a beard. Actually, this is my 8th grade graduation picture. Divine Infant Jesus Grade School, Westchester, Illinois, one of the near west suburbs, now near west suburbs of Chicago, 13 miles straight west of downtown. And the reason I like to start with this photo is that, and I do this often when I do talks for middle school and high school kids, is that it was around this time in my life that my dream of being a meteorologist was really starting to crystallize. Growing up, I was, like so many people in my field, I was kind of just really had a passion for weather as a hobby growing up. And I remember in 4th and 5th grade, and of course this audience will be at home with this, this is back in the days before internet and cable TV and satellite TV. So there were 3 TV stations that had news in Chicago, a CBS, an NBC, and an ABC affiliate. And I had figured out a way to be able to watch all 3 weathercasts in the 6 o'clock news at one time by switching the stations at the right time, because one of them had a little earlier and the other one a little bit later and the other one a few minutes after that. Of course, it drove my family nuts, but it wasn't just watching TV on the weather. I was really into watching the sky, and I did a lot of reading. And the town I grew up in, the Westchester Public Library, had 10 books about weather, and I had all of them checked out most of the time. In fact, I think I was in trouble a few times for having them too long, but that's another story. When I was in about 8th grade at this time, I sent a letter. Yes, I wrote a letter to the American Meteorological Society, which is our professional society for meteorologists in the United States. They're headquartered in Boston. And they sent me a big envelope. Took a couple of weeks, and it contained a giant list of all the colleges and universities in the United States that offered programs in meteorology. Because I was interested in knowing where you might study to do this, if you wanted to do this for a living someday, or to get a degree. And they also sent me a big booklet about careers in meteorology, and I was really excited about it, except for one thing. Practically every page of this book would say something about the importance of proficiency in what I now recognize as the beautiful language known as mathematics. Now, I didn't struggle in math, but it was not my favorite subject. Let me put it that way. I had to work harder at it than anything else. I much preferred geography and history to math, let me for sure. But you know what? That was an important message for me to hear, because that message told me that the road to a career in meteorology went through the math classroom. And I tell that to students a lot today, because I teach at UW-Milwaukee, and I work a lot with, and I've worked a lot in my years there with students that, we used to call it remedial math. We now call it developmental math. But there are students who are coming in shy of where they should be to get on the run for a college degree, especially if they're looking for a degree in a STEM field, science, technology, engineering, mathematics. And this is an important message to be heard. So what did I do? Well, I went on and I got 2 college degrees. I got a bachelor's degree in engineering applied mathematics from Northwestern, and then I did my master's in meteorology at UW-Madison. Now, a funny thing happened on the way to my degree in Madison. If you would have asked me halfway through my master's program, Bart, what do you want to do with your degree when you get done? I said, I don't know, work behind the scenes at the National Weather Service or some private forecasting service. Well, about halfway through my master's program, I was offered the opportunity to be a teaching assistant for a semester. That was a game changer, because I suddenly realized about halfway through my first semester as a TA that this is what God wants me to do. I love being in a classroom. And from that point on, my espoused goal was to be a teacher. And when I was finishing up my degree, I was already thinking that I wanted to stay in the Madison area because I got very involved in the Madison area, also working in youth ministry with high school kids. And I thought if I could find a job teaching either in a high school, earth science and math, or in a small four-year college like Edgewood, or maybe Madison area technical college, that would be ideal. So what happened? Well, like many of my classmates at UW-Madison, I thought, maybe I should get some experience as a forecaster first, just to say I did it for a year or so. So I went to work for a private consulting firm in Madison that a lot of my classmates also got their first experiences at. And the name of the company was Weather Central, and they did forecasts for a broad range of clients. So we did specialized forecasts for farmers in east central Wisconsin for crop dusting and haying conditions. We did forecasts for cranberry growers up in the Black River Falls area for cranberry bog temperatures. We did forecasts for electric power companies. We did forecasts for school districts. And we did the weather for over 40 radio stations in and around Wisconsin. And I was only there a couple of weeks, and my boss goes, "We need somebody else to do radio. Bart, give it a try." I was like, so in the school of learn by experience, I learned a lot in a big hurry about talking about weather on the radio. We also did the weather. Our company also served the TV meteorologist for one of the TV stations in Madison, WKOW. So I got a little bit of TV experience. Then I started looking, after just about 13 months there, I was looking full tilt for teaching jobs again. And what happened? Well, a funny thing happened. I got a call from a TV station here in Milwaukee, Fox 6. Well, it wasn't called Fox 6 back then. It was just called TV 6. And they offered me a job. I was like, I remember driving to Milwaukee with tears in my eyes. I was like, God, this is wrong. I wanted to be in Madison, and I'm going to Milwaukee. I do not want to be in TV. I do not want to be in Milwaukee. But here I came. And so I promised myself I was going to give it a try. I was going to do this job for 2 years, and then I was going to go back to Madison and live happily ever after. Well, as you can see, my 2-year plan went awry, and I was in the job for 28 years. And this always reminds me, and I tell students, one of my favorite Proverbs says, "A man's mind plans his way, but God directs the steps." And I got to tell you, I made a lot of plans that it was probably a good thing that they didn't come together, and they went God's way rather than mine. And this was one of them. I have to tell you, of course, first of all, a tribute to my news director at the time at Channel 6, Jill Geisler, who knew exactly how to woo me. She knew that I was not really interested in TV, and she said, "Bart, we are the community relations station. You're going to get lots of chances to go out at schools and teach. Maybe you might even have a chance to teach a class at UW-Milwaukee." Well, she was right. I mean, I did something like 1,500 school talks and tours in my years at Channel 6, and I had lots of opportunities to teach part-time in the atmospheric sciences program at UWM. And when my job ended at Channel 6 in 2010, I went right over to UWM, where I have been in heaven ever since, as lecturer in atmospheric science and mathematics. And so, like, for example, this semester, I'm a jack of all trades of sorts. So I teach Intro to Meteorology, which this is like the 20th semester I've taught it. And I never get tired of that class. I love it. And I also teach a survey of calculus course, which is also a favorite of mine. And then I work with a program that we have called Innovative Weather. Innovative Weather is kind of Well, it's kind of like a private consulting weather service, just like the one that I worked at my first year out of school. And it gives our students a chance to do real game condition forecasting. So we do forecasts for the Lake Express Ferry. We do forecasts for Summerfest. We do forecasts for electric power companies. We do forecasts for WUWM radio, if you ever listen to WUWM, the NPR outlet in Milwaukee. And to sort of keep myself in the loop with helping to train students, I do a shift a week, so you might hear me on there once in a while as well. So, and then finally, I still get to go out and do talks like this. And this is actually the best part of my job. I almost don't even consider it that. UWM has, over the years, they have had this wonderful public outreach science program called a Science Bag. There are free lectures in subtopic in science every Friday night and 1 or 2 Sundays during the school year. I did one program a few years ago on hurricanes and tornadoes. History is one of my favorite subjects, so I got to dress up as Sir Isaac Newton in Scientists Who Turned the World Upside Down. My dad was an electrician, and so I always had an interest in lightning and atmospheric electricity as a hobby topic, so this was one of my favorites in 2018. And just this past April, I did one all about maps. So kind of keeps me out of trouble, and of course, I still have my hands in operational meteorology on the weekends. I work a shift each week as a weather observer for the FAA down at Mitchell International. So if you're ever flying out on the weekend, I'm keeping an eye on the sky for you. So, okay. All right, just wanted to give you a little bit about my background. But let's get started here. I told you I've always been an avid lover of history, and I just want to say that a lot of this talk is founded in a love of putting history and science and math together, which I learned from my major professor. I'll never forget, when I was in graduate school, people always say, well, you know, Bart, what were your 2 best courses in college? Well, believe it or not, in my entire career at Northwestern as an engineering undergraduate, which was an excellent program, the best course I ever had was a course in New Testament origins. That's really when I started reading scripture. And I took that course as an elective, thinking, you know, I'm just going to take this course because I heard the professor was funny. Little did I know. And the other top course in my college career was a 700-level graduate course on the general circulation of the atmosphere. And it was taught by my major professor. Now, I will tell you that at that point in my academic career, I already had something like 42 credits of math beyond calculus under my belt. And I pretty much felt that there wasn't any math that I had never seen before. Wow, when I took that course, I was really scrambling with the mathematics. And it was a wonderful course because it was really my major professor's area of research. But you know what the best part of the course was? He would start talking, like one day we were talking about some of the theories of Edward Lorenz, who, by the way, is known as the father of chaos theory. He was a professor at that time at MIT. And he was considered a giant even then in the field of meteorology. And Professor Johnson turned around and he said, you know, I had lunch with Lorenz once when I was out there visiting MIT. And he started telling us about it. He was like, Lorenz was a quiet man, you know, he wasn't one of these people who, when you walked in the room, you knew he was there. And he said his wife was really a lot more talkative than he was. And you know what? I reflect back on that so often because I think, you know, what do I remember about meteorology 712? Do I remember all of the equations of the general circulation? Well, vaguely. But what I really remember are the stories about lunch with Lorenz. And it made me think, you know, why don't we teach science and math with stories of people? Because after all, what are people interested in most? People, not equations and machines. And so many of our equations have a person's name attached to it. Why don't we learn something about who that person was? So I've always made that kind of a focus in my teaching. So, well, let's get going. talk a little bit about history. So my title here is how weather forecasters changed history. And we want to talk about people and events surrounding the Russian winter forecast of 1941-42 and the D-Day forecast of June 1944. So let's transport ourselves. It's June 1941. And where are we? We are in Berlin. We are in Hitler's war room, where he is gathered with his generals, and they are planning a secret all-out assault on the Soviet Union. And they have nicknamed the operation Barbarossa. Barbarossa was apparently a great German warrior from past history. And this plan is meant to be a monumental knockout punch to strike into Western Russia and to go all the way to Moscow before the weather even gets cold. And they planned there to have 3 huge armies. Army Group North that was going to strike towards, well, Leningrad, which formerly and now once again is now St. Petersburg. Army Group Center, which was going to strike and drive all the way to Moscow, and Army Group South, which was going to strike into the oil and farm-rich Caucasus of the southern USSR, and eventually with the goal of taking the fortress city of Stalingrad. Again, the plan was to complete this takeover of the Soviet Union by the end of the summer. And this was a plan that at first worked perfectly. They launched the assault, and the Russian armies were reeling back when they struck in late June of 1941. And through July and into August, the German armies marched relentlessly across the far western part of the Soviet Union. But then an unanticipated complication came along in the late summer and early autumn. They ran into what are known as mud periods. Oh, I love the German word for it, Schlamm. So a mud period is a Schlamm period, or the Russian word for it is Rasputitsa. Well, what they didn't account for is that yes, there was a lot of rain in the late summer in the western part of the Soviet Union, and when the German meteorologists had looked at weather records, they said, well, there's not as much rain in the fall, but what they did not account for was that in this part of Russia, climatologically, they have a lot of overcast days in the early autumn. And so even though they don't get as much rain as they do typically during the summer, the cloud cover limits the amount of evaporation. So the differential between precipitation and evaporation is actually even greater. And of course, all of the roads that the German heavy equipment were moving on were dirt roads, and these dirt roads turned to mud. And the German armies became seriously bogged down. And in fact, and you can see, I mean, the trucks, these soldiers are waist deep practically in mud. The tanks were up to the top of their treads in mud and stuck. And it was really a pathetic situation. There were literally 6 weeks in the early and mid-autumn of 1941 where the German army didn't go much of anywhere because they were literally stuck in the mud. Now, this really altered the timetable quite a bit because now serious consideration was starting to be given by the generals of, we're not ready for the Russian winter. Our troops have not been issued cold weather gear. What are we going to do? So what they did was they thought, well, first of all, let's get an idea of how, can we get a fix on how bad this upcoming winter is going to be. So they consulted with a meteorologist who had a reputation for making long-range forecasts. His name was Franz Bauer. And Bauer issued a prediction for them for the western part of Russia for the winter of 1941-42. He said, this winter is going to be a normal to mild winter. How did he do that forecasting? Now you have to realize, I mean, climate forecasting, I mean, it's a tough sell, tough to do today, 3 months in advance. And he's working with the technologies of 1941. How did he come up with this? Well, quite simply, he looked at the winters previous. The previous winter of 1940-41 and the previous winter before that of 1939 to 40 had been particularly harsh in the western frontier of Russia. And he looked through records and he could find no instances of 3 consecutive harsh winters. So he said, that's it. It's going to be a mild winter. We've never had 3 harsh winters in a row. Okay, well, guess what? Verified. It turned out that the winter of 41-42 was the coldest winter of the 20th century in the western part of Russia. And it proved to be a near disaster for the German army. In fact, it was a disaster because snow began to fall earlier than usual in November. By early December, nighttime temperatures were dropping to 25, 30, 35, in some cases even 40 below zero. And the German army's soldiers were completely exposed. And they were dropping out of ranks due to exposure as frequently as they were dropping out of ranks due to the Russian bullets. And at this point, and I might also add that Bauer's forecast was bought by Hitler because Hitler did not want to listen to anybody else with a forecast that disagreed with his. One of his meteorologists that he consulted started to bring up the idea that we have to be careful here. There's bad history on our side. In the year 1812, Napoleon marched into Western Russia with his Grande Armée. Remember that story? I think he had like 500,000 men. I think he came out with less than 100,000. I mean, his army was completely decimated by exposure to the cold. And then he would say, Napoleon's leadership was greatly diminished and his power in Europe after that. Well, someone tried to bring that up, and Hitler forbade anyone from bringing up the winter of 1812 as an example. Kind of tough, when it's like the boss says you can't use all the data that you have. Yeah, not good. All right. So what happened? Well, we know the story. The German army drove to within 75 miles of Moscow. In the city of Moscow, you could hear the sound of the big German guns in the distance. But that's as close as they got. They literally were stuck and could go no further with their supply lines and with the bitter cold. And in many ways, historians would say that the Russian winter of 1941-42, more than anything, proved to be the decisive factor in the defeat of the German army and in preventing the defeat of the Soviet Union. Now, obviously, after this ill-fated decision about weather, there was some shakeup in the upper echelon of the German Weather Service. By the way, I would like to point out at the start of the war, the German Weather Service was a juggernaut. They had 1,000 meteorologists, many of them with a PhD equivalent education. By comparison, the United States Weather Service for the military had only 200 meteorologists, and many of them were only had some practical forecasting skills that they had learned. Well, anyway, there were some changes in the upper echelon in the German Weather Service, and the person who emerged as the new leader was Werner Schwarzenegger, who was a quiet scientist, but he became the head of the German Air Force Weather Center in at this point and till the end of the war. And I will tell you, Werner Schweitfeger made an amazing forecast for the weather for the Battle of the Bulge. In late 1944, when the Germans were planning their offensive in the Ardennes forest, they knew their Air Force was gone. And the only way that they were at the mercy of the Allied Air Force unless the weather was bad enough that they couldn't fly. And Schweitfeger predicted correctly that there would be 10 days, beginning in the middle of December, that the Allies would not be able to fly. And he was right, almost to the exact day. And the Germans struck in the Ardennes on December 16th, and they drove a big gap into the Allied lines, surrounded the town of Bastogne, and nearly pulled it off until the weather cleared, and they were able to be pushed back. And Hitler himself commented that about Schweitfeger that we have a weather prophet, he called him, who could make such a forecast. Now, the story goes, after the war, Professor Schweitfeger left Germany and eventually came to the United States, where he became a professor of meteorology at University of Wisconsin in Madison. All right, kind of an interesting intersection here. In the late 1970s, I was a young pup graduate student at UW-Madison, and I had Professor Schweitfeger for 2 of my major courses. He was a very interesting man. First of all, he had an incredibly thick German accent. I mean, you had to sit in his class for at least 2 weeks before you could get used to his speech style and understand him. But he was an impeccably organized teacher. He wrote everything on the board, and he had this perfect penmanship. And if you were like half asleep in class, if you just copied what he wrote on the board, it read like a textbook. And I'll never forget, his exams were very technical. And, you know, frequently the answers involved a lot of mathematical manipulation, and then the final answer would, of course, be some number, you know, some quantitative expression. But he had a rule. All final answers on exams had to be expressed in complete, well-written sentences in English. And it was so embarrassing. Some of us would get our paper back, and you would have the numerical answer correct, and you would write in big red letters at the top of your paper, "Learn English." Coming from this man who we could barely understand. So, well, I would just like to say, I always counted myself very blessed that I had an instructor with such incredible background and experience as Werner Schweitfeger. And it was really a part of what I consider a very rich experience as a graduate student. All right, let's switch gears. We'll jump ahead 3 years, and now it's June of 1944. And we are in the Allied War Room in London, where Dwight Eisenhower is gathered around with the other Allied generals, Montgomery from Britain, de Gaulle from France, and they are just frustrated beyond all because they have been planning Operation Overlord, the Allied invasion of France to liberate it from the German armies. And their plan was originally to go in May, but it has been so stormy in the English Channel region, more like March than May or early June. And they have had to delay the invasion over and over again. By the way, just a little reminder of the invasion plan. So this is a map of France and the English Channel, and the Allies were staging and arranging all their armies in far southern England. And the plan was, they planned a ruse to go across to try to trick the Germans into thinking they were going to go across the Strait of Dover, which is actually the most narrow point in the channel, and strike at the port of Calais. But instead, they went across at the longest distance across the channel and attacked at 5 beaches, codenamed Sword, Juno, Utah, Gold, and Omaha. Well, again, the weather was a serious problem. Now, the Allies had a crack weather team headed by a British officer named Stagg, and his forecast group was split into 3 groups, and he gave them each group a chance to work independently on the forecast. Now, the group that he wound up paying the most attention to was headed by a young Norwegian man named Sverre Pedersen. Pedersen had belonged and acquired his meteorological education working for the famous Bergen School in Norway in the time of World War I. But he was a unique blend of theoretician, mathematician, and practical forecaster. And Pedersen and his group constructed charts. By the way, here's Eisenhower. Talk about pressure. This is the boss you got to answer to? Wow. He says, what's the weather going to be? But that would really make me nervous. Anyway, yes. So here are some of Pedersen's charts from the 1st, 2nd, and 3rd of June, 1944. And I'm not going to go into detail about them, but you can see they're a little bit hard to see. This is, you can see over here the British Isles and Norway. Well, but the thing is, what's astounding is that he was able to draw these charts using such scant data. I mean, there were no satellite images, there were no balloon observations, hardly. There was no radar, and half the weather stations that he would have liked to have plotted on a map were in the hands of the Germans, and they weren't sharing the weather data, to be sure. So, but nonetheless, through this, it turned out they told Eisenhower that we think that there is going to be a brief period of calm around June 6th. And this was important because I think the last day that they could possibly go was June 7th. And after that, they would lose the cover of new moon and the tides would be wrong, and they would have to wait until practically July to try again, which they certainly didn't want to do. Now, what is amazing is, and here's a forecast chart that Pedersen drew for June 5th of 1944. On June 4th, the weather was clear in the English Channel. And Pedersen and his group told Eisenhower that the next day, June 5th, was going to be terrible. Eisenhower trusted his meteorologists and decided not to go on June 5th. The next day, June 5th, the weather was terrible, as predicted. Pouring rain, driving wind, high seas. And now again, he talks to his meteorologists, and they say, tomorrow is going to be good. Again, Eisenhower, on a day when the weather is anything but what it's going to be like the next, he trusts his meteorologists. And June 6th, indeed, turned out to be the right day to go. Now, I will tell you that for his gallant efforts in weather forecasting, Pedersen received a letter of commendation from Eisenhower personally, which he always treasured. He went on to, after the war, he came back to the United States, and he was on the faculty at MIT and then eventually the University of Chicago, where he actually published a landmark paper developing some theories in forecasting that operational weather forecasters such as myself make use of practically every day to this day. And while he was at the University of Chicago, he actually took a sabbatical at one point in 1971 and spent a semester as a visiting professor at UW-Madison. That was a little before my time, but I still heard stories when I had arrived on the scene as a graduate student of people who had heard lectures given by Sverre Pedersen. Of course, we're all like, oh my gosh, this is like, this man is a giant, and to have had the opportunity to be in a classroom with him. All right, so I guess that's the story of what happens when a weather forecast goes very wrong, and another story of what happens when a forecast turns out to be very correct. Let me just stop at this point. Are we doing okay?
Yeah.
I have 3 stories, and this is 2 of them. So, but if anybody would, we're okay on time? Okay. So let me tell you another story. Now this one's, in case you thought there would be no math in this, the one thing I have to forewarn you, there's a little bit of math in this last story. But I promise to make it fun, I hope. All right. I'm serious. One of the things about math, I believe, is attitude. And I tell my students that I really believe it. Math is a language. And sometimes we shy away from math, and that causes us to be resistant to practicing at it. And I tell my students, if you want to learn French, can you learn French by studying 1 night a week? No way. 2 nights a week? 3 nights a week? Still doubtful. 4? Maybe we're getting somewhere. 5? Okay, now we're doing business. You have to have an immersion experience. The less you like it, the more important it is to immerse yourself to finally acquire some comfort and proficiency level with it. All right, so actually I wanted to give you share this one quote from Pedersen. I love it. On the subject of weather forecasting, he said, "It is exciting. The competitive instinct, or whatever else one wants to call it, grows and drives the forecaster to action. Careful action. A storm is neither a friend nor an enemy. It cannot be controlled, praised, or punished. But it must not come unannounced." That is the terror of all meteorologists. The storm that was not foreseen and that surprises everybody, including the forecasters. All right, speaking of forecasts, this is really the story of modern meteorology. The beginning of numerical weather prediction. And the story begins not with mathematics, but rather with the story of a man named Lewis F. Richardson. Richardson was a brilliant mathematician and living in England, who became interested in how one might use mathematics to predict the weather by calculating the future weather based upon the present. Now, I must tell you, Richardson was a very spiritual man. He was a Quaker and a deeply avowed pacifist. So when World War I broke out, he refused to take up arms, but he volunteered to be an ambulance driver and risked his life in the Battle of the Somme. But while he was there in Europe, some ideas that had been percolating in his mind for quite a while, he had some time to work on. And after the war ended, he published in 1922 an amazing little book called Weather Prediction by Numerical Process. And in this book, he took, and of course we always stand, nothing happens in a vacuum, the equations that could actually be used for weather forecasting were developed by a Norwegian mathematician and meteorologist named Wilhelm Bjerknes around the turn of the century. Bjerknes actually founded the Bergen School in Norway that Pedersen belonged to. And, of course, Richardson was well aware of these equations, but nobody thought that there was any way to practically solve them. Well, Richardson started developing some methods for practical solution of the equations, he thought, and here's how it works. Now, we always hear this word that terrorizes people in math, equation. What is an equation? An equation is a statement of relationship. It's a statement of relationship among quantities, among variables. Now, when it comes to the atmosphere, there are actually 6 relationships, 6 equations based on the laws of physics that describe the way the atmosphere operates in time. And there are 6 variables: pressure, temperature, humidity, and wind. And no, it's not that Bart can't count. I know it says there are only 4 words, but wind is actually 3 variables. There's a north-south component of wind, east-west component of wind, and an up-down component of wind. So wind is actually 3 variables. Okay, so I know all of you have had enough math to know that you learned somewhere in algebra that what? If you had 2 equations and 2 variables, x and y, you could solve for x and y. We call that a closed system. Well, it's just a little more complicated. Here we have 6 equations and 6 unknowns, but we could still solve for them. And we say that this is a closed system also. And Richardson recognized this. So he came up with a scheme to do it. Now, first of all, let me say, this is not a calculus lesson. These are the so-called primitive equations of the atmosphere, and they are written in the notation of calculus. But what's important that I want to point out is that this was so, in its essence, back to basics. Because what are those first 3 equations? Those first 3 equations are basically what we call the momentum equations of a fluid. They basically summarize, in technical notation, the second law of motion of Sir Isaac Newton. Force equals mass times acceleration. F equals ma. The third equation, the fourth equation, is actually also from one of Newton's laws. You know, Newton had this famous conservation law that it was called the law of opposites. For every action, there's an opposite reaction. So out of that, we come up with conservation of mass, which is also, meteorologists like the fancy term, we call it the continuity equation. The fifth one is the conservation of energy as expressed by the change in temperature. And the last one is the conservation of water vapor as expressed by relative humidity or dew point or whatever moisture variable you want to use. Okay, so Richardson's idea is that we're going to take these 6 equations and we're going to take the 6 variables that we're going to measure, and we're going to put that data in here, and then we're going to calculate the solution to these equations forward in time. We are going to calculate future values of temperature, pressure, humidity, and wind based on the present. Now, if I can tell you the temperature, pressure, humidity, and wind at some time in the future based on the present, what do you call that? I call that a weather forecast. Okay? And that's essentially what we're doing here. Now, here's Richardson's scheme on how it's going to work. He said we're going to have computers. Uh-oh, careful. What does he mean by computers? The year is 1922. His idea of a computer is a human being with a pencil and paper. And his idea is that we're going to have an auditorium full of meteorologists. And they're going to be gathered all around this giant auditorium, and everybody's going to be working with pencil and paper to solve these equations forward in time. And he's going to have somebody sitting in this podium here, almost like a concert master. And if one section of the group is doing their calculations a little too fast, he shines a blue light on them to tell them to slow down. And if another group is going a little too slow, he shines a red light on them to tell them to speed up. Well, they attempted to make a forecast for a couple of points in Central Europe, which they already knew what the weather would turn out to be like, but they wanted to see if their forecast would match what the actual weather was. So they went ahead and they tried to make a 24-hour forecast. Guess how long it took them to make do the calculations? 6 weeks. Yeah, laborious. And how good did the forecast turn out? Not very. They basically came up with a prediction of a near hurricane in Central Europe, which had otherwise verified as a relatively calm day. So, in a sense, it was a failure. And Richardson, while not entirely discouraged by that, what nailed the coffin for him on being involved in weather forecasting is he found out that the military was interested in his forecast techniques for battle planning purposes. And of course, from his pacifist stance, he could not live with that. So what did Richardson do? He went back to school and got another PhD in psychology. And in the 1940s, he published some very interesting papers on what he called the mathematical theory of war, where he literally tried to prove mathematically that war was no practical way to solve disputes. As you can tell by the state of the world today, not enough people read his papers. But a very interesting man of peace, Lewis F. Richardson, and made a phenomenal contribution. Now, the story doesn't end here, because this seems like a defeat. But what Richardson could not have imagined in 1922 was that 28 years later, in 1950, a group of incredibly talented scientists and mathematicians would be excitedly gathered at the University of Pennsylvania in a building with this monstrosity called the ENIAC, Electronic Numerical Integrator and Computer, the granddaddy of the modern digital computers. And the ENIAC was used to generate the first computer-run weather forecast. And of course, it had its drawbacks. More on that in a moment. But I have to tell you, it was an amazing group of people who assembled to make this happen. And they were all trying to capture Richardson's dream. And one of the people, I don't have time to tell you about all of them, but let me tell you about one of the more interesting ones. He wasn't even a meteorologist by origin and training. His name was John von Neumann. In case you've never heard of him, there are a lot of people today in the know who will say that John von Neumann is arguably the smartest man who ever lived in pure intelligence and because of his mathematical abilities. And von Neumann was Hungarian, came to the United States with the rise of Hitler's Germany. And during his career, he made some incredible contributions. Some said that he was the last representative of the great mathematicians who were equally home in both pure and applied mathematics. And he made contributions in what is known as game theory, in quantum physics, and he worked prominently on the Manhattan Project in developing the nuclear bomb in World War II. He was a master of mathematically modeling explosions. And, but he also did work in fluid dynamics, which led him to interest in modeling the fluid atmosphere. And he also was at the forefront in developing methods of digital computing. So you can understand how he got involved in this. Now, by the way, so I have to tell you, so he's a very interesting man. I read quite a bit about von Neumann. So apparently, he was very gregarious. He loved jokes. He loved parties. He and his wife threw parties all the time. His wife once said of him that John could count, the only thing that John couldn't count were calories. And he was notorious. He had a sports car that he drove too fast and got tickets on all the time. He was on the faculty at Princeton University. And there's a story that in his office, he loved to play jazz music, but very loud, and which greatly annoyed a professor 2 doors down the hall from him by the name of Albert Einstein. So, can you imagine this? He annoyed Einstein. I'd hate to be in the hallway where those two were arguing. Oh my God. Can you imagine? Anyway, back to the ENIAC. So, they made a forecast, a 24-hour forecast. Now, it still took 72 hours to run, but it was off and running. And computing speeds only went up from there. By the way, the ENIAC operated on vacuum tubes. Here's my one prop. Any of you familiar with these? I mean, used to be, when I was growing up, the television in my house had about 20 of these. Everybody's TV did, before the days of solid-state electronics. And I still remember they generated a lot of heat. My dad used to have to go and check them every so often. There was a testing station in the corner drugstore. And my dad would take them all over there and test them out. Oh, this one's bad, we got to get a new one. That'll make the picture better. And they were notorious. Do you ever remember this growing up? You had to let them warm up before they came to peak operating capacity. And my brother and I, there was a program we liked to watch called Lost in Space at 8 o'clock on Wednesday nights. And I always remember we used to have to keep an eye on the time. So 10 minutes to 8, we had to make sure we got home and turned on the TV so it would be properly warmed up so we wouldn't miss any of the show. Vacuum tubes, yeah. So anyway, the ENIAC operated on these vacuum tubes. They generate 18,000 of them. There was a rumor that when they turned the ENIAC on that the lights dimmed in Philadelphia, which was a few miles away. I don't think that was true. Pretty funny. Amazingly, the ENIAC ran at a computing speed of 5,000 flops. Flops, that stands for floating point operations per second, which is basically calculations per second. That's the speed of the computer. Let me tell you, my first calculator, which was a TI data math that I could add, subtract, multiply, divide, and do square roots, could go faster than this. And, but computing speed rapidly changed. And you know, so today, just as of the end of June, the National Weather Service upgraded to an even newer and more powerful generation of computers to run their weather forecast models. And the computers run in tandem. There's one major computer is located in Manassas, Virginia, and the other one is right near Phoenix, Arizona. And they nicknamed the computers Dogwood for the predominant vegetation in Virginia and Cactus for the one in Arizona. And the combined computing speeds of these two computers is 24,200 teraflops, 24,200 trillion calculations per second. Or if you prefer, the new unit that we like to use because it's convenient is the petaflop. A petaflops is a quadrillion operations per second. Unbelievable. And of course, this has really propelled weather forecasting to skill levels and range and accuracy that we never imagined, and certainly that Richardson and even von Neumann could not have imagined when they first ran the ENIAC forecast in 1950. Okay, I think I should stop here, giving you enough mathematics. I really mean it. Math is a language. It is just a language in which we can express quantities and relationships. And it's a beautiful language. Some say it's God's language because, you know, if I have a friend in China and I don't speak Chinese, but if he or she is fluent in mathematics, we can exchange equations and know what each other is talking about. So, all right. Any questions, comments? Yes?
What do these teraflops have to say about climate change?
Oh, well, you know, this is something that's deeper than just computing speed, of course, but climate change is real. It's a difficult question, and sadly, in our society right now. I get asked this all the time. People say, you know, do you believe in global warming? I don't believe in global warming. It's not a religion. I understand global warming. But it's, you know, why is it different from anything else? So I don't know where to go exactly with your question because it...
It's pretty vague. I mean,
yeah. Well, no, but I mean, well, let me just say, I mean, I know that I just read an interesting book this summer that I couldn't put down by a man who was a highly skilled nuclear physicist that had quite a career working at Los Alamos National Laboratory for many years, and then he became an ordained Episcopalian minister. And he wrote a book about reconciling faith and science, and I really liked it a lot because it tied together some things. And he talked about how do we know something is true? And of course, this is probably a deeper thing than just the question of climate change. But he said, you know, first of all, there's direct observation, and he used these great analogies. He said, well, at least for me, because he used meteorological. He said, how do you know it rains? Well, you go outside, you stand outside, you feel drops and get wet. That's direct observation, right? Okay, but what if you weren't there? But if you had a rain gauge that was sitting outside overnight, and you got up in the morning, the sun might be shining, but you look and you see 2 inches of rain, of water in the rain gauge, and you know that's evidence, indirect, that it rained. And then he said, and then the other thing, way of knowing is, okay, maybe you didn't have a rain gauge, but maybe you had a friend who was out during the night, and they came, and you trust your friend, and they came and they told you, yeah, it was raining at midnight, I got wet. Okay, so you trust your witness. And, but then he particularly hones in on the idea of relationship and knowing through relationship. And this really kind of connects to the idea of faith too, because he talks about how in our relationship, for example, with a doctor, we might start out by believing going to a doctor just because of reputation. But then we start to note that the doctor really cares for us, and even though the doctor might prescribe some therapy that we don't completely understand, we trust the doctor because we know now from the relationship that we've developed that the doctor has my best interest in mind. It's kind of a little bit like that, I think, with God. And I thought a lot about that in terms of some of the difficulty that scientists have had with communicating information about climate change. It's a difficult thing because there are those who would like to portray the scientific community as being much more divided about this than it is. On the fact that climate change is happening, the fact that it is happening at an alarming rate, and the fact that there are anthropogenic causes, human activity, that are responsible for this, largely the burning of fossil fuels. And that is a difficult sell, I think, because people have cast doubt on that. And science is, I guess I would just share this, science is not an arena where you're going to find complete lockdown, unanimous agreement. You will always be able to find someone who disagrees. All the scientists I know are the most disagreeable lot of people I've ever met in my life. And of course there are people who say that scientists are conspiring to trick us into thinking that climate change is happening or that we have something to do with it. I can't even get the scientists in our little group at UWM to agree. How can I get 1,500 scientists on the Intergovernmental Panel of the United Nations to agree on all the same things? I think that is one difficulty that we have, when it comes to science. And I guess the last thing I would say is I've sometimes thought in terms of climate change about other questions, like, for example, take smoking. In 1965, the Surgeon General dogmatically proclaimed that smoking is bad for your health. Okay. But you could still find doctors at that point who would say, go ahead and smoke, it's good for your nerves. And can you still find doctors who would say that? I'll bet you can. Not many, but if you can find a doctor who says that it's okay to smoke, does that mean that, all these other people are wrong? Well, no. It's just a dissenting view. Kind of a weird dissenting view, I might say, but you know what? A dissenting view. And the presence of a dissenting view does not mean that the larger view and the preponderance of evidence that everyone else is looking at is wrong. So, all right. Vague question, so I thought I'd give a broad brush answer. I don't know, I hope I touched on something.
Well, it's just you get more information, right? Because you got these more information to be looked at. So therefore, maybe.
Right. And I will tell you that when when the terminology of climate change, global warming, first emerged, I still remember it got into the media after the hot summer of 1988. That summer we had 36 days of 90 or higher here in Milwaukee, 6 days over 100, amazing. And this terminology, global warming, started coming out. Well, that was a little bit ahead of where the science was at the time, and it created some predicaments. But the research has mounted over the years that have made it really difficult to argue with the original theories at any point. And the question is, are we willing to do something about it? Stay tuned. Anyway, any others?
More questions?
Well, I just want to say thank you very, very much for your time and attention today. I really enjoyed coming down here to visit, and have a great afternoon. And just remember that the weather forecast you watched started out with a bunch of equations being solved this morning. Thank you. God bless.